often wondered about what we've been looking into, and I'm very grateful for the input and the work to what we've done so far to Jessie Colbert and Dan Exeter from School of Population Health in the University of Auckland in New Zealand. Okay, so linking individuals to areas, protecting confidentiality while preserving research utility. So a regular line of inquiry that many of us would carry out is whether levels of an outcome, whatever that may be, for an individual relates to the type of area in which they live, such as the level of deprivation. But a tension exists between making data available which protects the confidentiality of individuals while containing sufficiently detailed geographic information to underpin the utility of research. And one of the challenges is that linking individual records to very small, very local area geographies might itself be disclosive. So this is not presuming necessarily that the smallest areas are the right analytical geography, but it is something which researchers often wish to do. Therefore, there's a kind of demand to do this. Life is not always about your local area, but it is often thought to be. So sort of underpinning the line of inquiry here is, if you don't or can't link as locally as you believe is ideal, how far away from residential locations can geographical identifiers be before a different conclusion would be made? So in this talk, I'm just going to have a couple of slides on data confidentiality considerations. Just a reminder about UK postal and census / administrative geographies, many of which you'll be familiar with, but it's worthwhile refreshing what these mean, what they are. A specification of the data sets being used here, and then using those data sets, the combinations of outcome compared with exposure geographies. We've investigated the interplay between two geographical entities, so points for the observations and polygons for the area attributes at a variety of scales. So what we're going to show here is that we do this for individuals located by their postcodes, unit postcodes, by the centroids of postal sector and postal districts, so progressively larger geographies, and link these to a variety of census geographies. And then a little bit more sophistication, jittering the postcode coordinates, which I'll explain in a while, to test the effect of moving people away from their original location. So having done that, we quantify misclassification for whether individuals are linked to the wrong area type. So we're doing this purely cross-sectionally, even though this is a longitudinal network. But it's relevant to any longitudinal work, but inevitably will be more complicated, and for what we're doing isn't really needed. So in terms of data confidentiality considerations, this is a sort of broad overview of elements which we often have to think about. There's a data collection phase whereby an organisation or an individual decides to collect data, be it a survey, census, store cards, whatever. And they plan the level of detail to ask people whilst assuring good governance, of course. So the level of detail affects people's willingness to answer the questions, to respond to said survey, and also later perhaps the research potential. So one might ask how old somebody is, and you might try and get the information by date of birth, how old in the years, or a tick box on an age group. And all those relate to willingness and research utility and so on. In terms of where somebody lives, we might ask them their address, we might ask for their postcode, or a more general location than those. During a data processing phase, there might be some adjustments that affect the data quality, research integrity, which might be for better or for worse. And then there's a data curation or release phase. And paramount to the data dissemination, making things available, is that the confidentiality of individuals is preserved. And many of us will also be used to working in this kind of 5 safes environment, that there's a requirement by ONS, UK Data Service, and other repositories around the world for there to be safe projects, safe users of the data, safe settings for access to the data, safe data specifications, and safe outputs. So we're predominantly here thinking about safe data specifications. So again, more about confidentiality considerations, combinations of attributes, say age, sex, tenure, ethnicity, health status, and so on, might be observations which are unique or considered to be small cell counts in the population or sample that may in themselves be disclosive. And where geographical location is included, disclosure risk is heightened. Geography seems to be the poor relation here in that it's always the last thing that's added. Geography itself is not disclosive. Just knowing that I live in Skipton doesn't identify me as a person as such. Attributes may be grouped, age group and so on, or ethnic group and so on, and geographies may be coarsened from more to less local, small area up to larger areas, say. But a tension exists between making data available, which both protects the confidentiality of individuals, whilst containing sufficiently detailed socio-demographic and geographic information to underpin the utility of the research. And we contend, it is likely that both supplier and user do not know the degree to which decisions made in the collection, processing, or release of the data affect the utility of the research results. So the intention here is to inform data collectors and suppliers about geographic choices for confidentiality protection and to have advice available to provide a degree of reassurance to survey and census respondents that what they're providing is okay, and information to the research community on whether data may be fit for purpose. Okay, so a quick revision on postal and census geographies. So the left-hand side of this screen, the bottom left, there's a postcode BD231UH. That is not my home postcode. It is actually probably about, I'm looking out the window, 500 meters away or something, but it's actually a postcode I've used as an example in some other work. So I've just continued with that usage. So although a postcode itself is kind of a set of houses, we geocode those usually as a point. We have a larger level of postal geography called postal sectors, and higher still postal districts. They are all designed for the delivery of mail, not necessarily as research analytical geographies, but they are progressively larger. We're going to be using centroids in this work. So where a unit postcode is a point, the centroid of the sector or the district is the geometric centroid of the polygon as provided, or can be the average of the postcodes with a truncated alphanumeric. On the right hand side, we have the census geographies from the smallest at output areas up the hierarchy through lower super output areas and medium super output areas, and then local authority districts. So the size of these circles there is kind of just an approximation of how those geographies kind of relate to each other in size. The local authority district circle is dotted because actually that's, although these aren't to scale, that is much larger than actually I've got appearing in this diagram. So the thoughts here is that the kind of the arrow up the middle is going from the bottom, which is potentially most disclosive, most detail, and as we go up we end up being less disclosive, but the query is, does this mean that the research is then less meaningful? Okay, to kind of map some of those things, so you've got a picture in your mind what some of these things might be looking like. So the square on the maps is the unit postcode location. The triangle on the map is the centroid of the postal sector. The district centroid doesn't appear on this map because it's somewhere else, but it does fall within Craven district. This is a map of Skipton, where I live. What we have there on the left-hand side is the output area geography from 2011. So you can see, hopefully, that the square falls in one output area, the triangle within another. yet on the kind of in the middle of the slide, the lower super output area geography, the square and the triangle fall in the same lower super output area. So the sort of question underlying here, does it matter? Does it make a difference when you have area attributes attached to the output area or the lower super output area, or indeed the other geographies that we'll explore? Okay, so in terms of the data that we're using here, we've put together a synthetic microdata set of about 22,000 individual records. They are located by approximately 20,000 unique postcodes, which is approximately 1.5% of the number of postcodes in England and Wales. The distribution of these is deliberately around 20% by Townsend deprivation quintile across England and Wales. And the attributes, the individual level attributes, are kind of plausible attributes rather than being strictly representative. The aim here is for geographical versatility as much as anything else. So the actual sort of emulation of a research approach is to do some logistic regressions. So the outcome of interest is whether or not reporting good health in relation to individual attributes on this synthetic file of age group, sex and qualifications, and to level of area deprivation. So we have individuals linked by their postcode points to the progressively larger OA, LSOA, MSOA and LA geographies, with deprivation calculated for each level of geography. Then the strategy is to coarsen the points to the postal sector centroids and do the same linking, coarsen the points to postal district centroids and do the linking, and then run these logistic regressions for every combination of those. So this is kind of tactic number one, linking to geographical areas larger than the most local. So this is something that any of us might do and or be constrained to do because we've only got the individual attributes linked to a particular geography. So here, the sort of left-hand side of the graph are the coefficients for the reporting of good health by deprivation quintiles. So quintile 1 is the line across the 1, and then by quintiles 2, 3, 4 and 5 at output area level, we have a gradient of progressively less likely to report good health with increasing deprivation. So the kind of thing that we would expect in terms of relationship. When we go up a level of geography to LSOA, the gradient is slightly less steep, same to at MSOA level, and then we have much more of a flattening at the LA level on the right-hand side. So what we have there is a kind of smoothing of the relationship. We have less difference for this relationship as we go up the geographies. So that is probably something that most of us would have been expecting. That's a kind of standard expectation. So this is not to say that just because a relationship there is less clear, smaller effect sizes at LA level, that's wrong. Because many analyses would be the right geography for the particular analysis that you're doing. But we would generally find more differentiation at local level and less as we go up the geographies. So that's kind of the starting point. So if we then go up the kind of linkage element, so postal sector centroid, so we've lost some detail from where people are located, and we have similar kinds of results, but rather attenuated across the geographies. So not a lot of difference between OAs, which kind of fall within postal sectors to a large extent. LSOAs and MSOAs are similar, MSOAs slightly larger geography as an entity, and the LAs a very similar result to the postcodes because we've kind of gone up another geography there. When we coarsen the points to the postal districts, we kind of lose much more detail again, such that there's very little differentiation for the within local authority district geographies, but something similar going on at local authority level. Again, districts are inherently smaller than local authorities, so they kind of fit within them to some degree, although not strictly hierarchical, of course. Okay, so from the three previous slides, this is now putting the graphs alongside each other. What we've got there is increasing coarseness of points from top to bottom and sort of from left to right, certainly for the postcodes, a little bit for the postal sectors. We have a smoothing of the relationships as we go up the geography, but as we lose the detail from the points, we differentiate less as we move from postcodes to sectors to districts. Okay, but when we talk about local authority, actually there's very little difference on what you're linking to those. Okay, so that's kind of tactics 1 and 2, link the postcodes, which we would think of as being ideal, coarsen the points, tactics 2 to sectors or districts. And postal sectors is often something when you're depositing data that you're encouraged to do rather than deposit postcodes. Okay, so tactic number 3 is blurring the original postcode location. So we're jittering the grid reference away from the original unit postcode locations. So for each synthetic individual observation, we jitter the grid reference coordinates away from the original unit postcode locations. So the X and Y coordinates are adjusted incrementally, plus or minus randomly, a specified distance from the original. So since both the X and Y are changed, the new locations are diagonally away from the original. So we iterate that 100 times at each distance. So from the original location, 100 meters, 250 meters, 500 meters, 750 meters, 1,000 meters, etc., etc. So these jittered locations are then linked to the OA, LSOA, MSOA, and LA geography, and models run for every iteration of distance variation and linkage. So what this gives us is a greater range of possibilities than the static postal geography centroids for assessing the distance away from the original for if the outcome deprivation relationship changes. So this then is the odds ratios for this blurring the postcode coordinates tactic. So the graph on the X is the increasing distance from the original, so 100, 250, 500, 750, and so on, up to 4,000 meters, 4K from the original place. And with 100 iterations, it gives us the distribution of the odds ratios. So these are plotted here as box plots for each quintile. So again, what we've got is the one line for the reference category, the least deprived, and then that we have a reduction in odds of reporting good health with increasing deprivation. So what you can see here, hopefully, is that as you move away from the original location, the difference between the quintiles gradually reduces until you get a point where you have overlapping distributions of the odds ratios generated by the iterations. So a kind of interpretation here is that if you took any kind of one combination of X and Y's from these jitters, would you actually interpret the outputs in the same kind of way? So what I've done on the right hand side here is just do a screenshot of part of this, because if you look at the sort of 500, 750 and 1,000 meters, what you start to see is this seems to be the sort of distance away from the original at which the distributions in these box plots start to overlap. So you've gone from a situation whereby you would say kind of statistically a significant difference between the quintiles to something which isn't necessarily different. And as you move further away from 1,000 meters, most of the distributions are overlapping to a large extent. Okay, so that's the OA example. So that's the most local level. So what I've got here is all 4 census geographies. So the OA one is repeated top left, top right, the LSOA version, MSOA version, bottom left, and LA's bottom right. So what you kind of have for the LSOAs and MSOAs is a fair difference between the odds ratios for the reference level and quintile 2, the next deprived, as it were. So quite a gap for some time, but then similarly actually to the output level around the sort of 750 meters away from the original is when the distributions start to overlap, and the differences beyond there start to overlap even more, resulting in kind of no difference at whatever distance away, but somewhere around the 750 meter mark away from the original seems to be about the break point of there are differences and then there are no longer differences. At LA level, the distributions are pretty tight because you still are only talking about the postcode locations and relatively small distances away, and it's not until you move through to sort of 1750, 2000, that sort of, you know, a couple of K away before you would start to actually conclude anything different. Okay, so if people are linked to the wrong area, as it were, this will be a kind of misclassification of the exposure, and misclassification can lead to errors in models and so on. What we wanted to do was quantify the degree of misclassification. So we can quantify using the linkages to levels of deprivation with the postcode point linkages as a kind of an ideal, and the differences for the alternative linkages using the sort of centroid for sectors and districts, so the coarsening approach, and then the at different distances away from the original postcode points, the jittering approach. If you do some of these movements away from the original, actually some points don't get linked that originally were, if the alternative location falls then outside of the study area or into a watercourse or into the sea or something like that, which some of them do. So the way we've done this is to take the distribution of points by deprivation quintile. So the left-hand panel of this table is the distribution of postcodes across the OA, LSOA, etc. geographies. Then, just as an example, the sector distribution is the centroids is the linkages is the middle panel, and then the differences are there on the right-hand side. So you have positive where there's a gain, negative where there's a loss. So to graph those, what we've got here is the difference between the sector centroids compared with postcodes in the top graph, and then the district centroids compared with the postcodes in the bottom graph. Okay, so what we have here is a loss and a gain. So below the 0 line, there are fewer postcodes linked to those particular quintiles, and above the line there are more postcodes linked to those particular quintiles. So comparing sectors with postcodes, the top graph, the losses are from the more deprived quintiles, and the gains are in the less deprived quintiles for the OA, LSOA and MSOA geographies. At LA level, there's hardly any difference. There's much more difference for using the postal district centroids. So we have relatively more losses from the more deprived and relatively more gains in the less deprived areas, and some differences at LA level, but more differences for the within LA geographies. Okay, so now this is the jittering approach. So again, along the x-axis here are the distance away from the original point. For the OA geography, top left, again, the losses below the zero line, the gains above. And again, this is losses from quintiles 3, 4, and 5, and gains in quintiles 2 and 1 as you progressively move away from the original location. The same is also the case at LSOA level and MSOA level, although the sort of fan point starts slightly further out than at OA, the smallest geography level. At LA level, when you move away from the original postcode point, it takes further distance away before it starts to have an effect. But for all of these, it's losses from more deprived area and gains in less deprived areas. Okay, so thinking this through about why that might be, the losses and gains, the differences in the classification between the original points, the areas, and alternative points is area size dependent. So the OA, LSOA, and MSOA geographies are delineated to have as even population sizes as possible. And as a result of this, census geographies in urban areas tend to be smaller in areal extent than those in rural areas. So the distances to the wrong area may be shorter in urban and longer in rural areas. And this matters if neighbouring areas are dissimilar in characteristics. So trying to capture both the size element and the sort of degree of urbanness and rural. There is no urban-rural classification for OAs, LSOAs, and MSOAs, but there is a classification for England and Wales at LA level in 2001 and for England in 2011. So what we've done here is to investigate the differences for areas within these LA types, and by combining the 2001 and 2011 information and simplifying slightly. I think it's a 6-level classification in the original files. So the map at the top right there, we have pink is predominantly rural areas, the red ones are urban with significant rural, and the darker red-brown is predominantly the urban areas. I don't know whether you'll be able to see it terribly clearly because it's not the best chosen colour scheme, but the kind of screenshot of a map below, the sort of yellowy area is Leeds, in fact, which is predominantly urban. And although it's green, the area to the right or east in geography speak is predominantly rural. There's some green dots near the border, which are the postcode locations, and the green triangle is a centroid, which is located outside of Leeds. So that kind of is a sort of shift that can happen when you locate people by different coordinates. Okay, so this panel looks very complicated, but the patterns are quite similar. And I've so that the top row, as it were, is all OA geographies, then LSOAs, then MSOAs, and LAs at the bottom. And the left-hand column, as it were, are all urban areas. Middle is urban with significant rural, and the right-hand side are all rural areas. I've superimposed some dotted lines at this 750 metre away from the original point mark, because that was roughly where things start to change in terms of overlapping odds ratios on those box plots previously. So these are the gains and losses for the misclassification. Again, if we sort of look down the urban column, there are losses from quintiles 4 and 5, not so much from the middle ground of quintile 3. gains in quintiles 1 and 2. However, these losses and gains are not large, particularly at the relatively short distances away from the original postcode. For both urban with significant rural and for rural areas, it's a more marked difference that there are rather larger gains in the less deprived areas and losses from the more deprived areas in terms of this comparison of the linkages than in the urban areas. So it seems that distance matters a bit more in urban with significant rural and rural areas, that when you locate the point away from its original location, it does tend to be in a differently deprived area. Okay, so to sort of recap on this size may matters. So the aerial extent shown here in mean hectares as the gradient from smaller to larger areas goes from more to less deprived. So if you look at the sort of top panel there of predominantly rural, on average, deprived, quintile 5 would be 13 hectares, quintile 1, 352. If you look down at the bottom of that for predominantly urban, the most deprived quintile 5 are mean 6 hectares and least deprived quintile 1, 46. So that kind of illustrates that the sort of both the urban, rural, and that there's a gradient from more to less deprived in terms of size of areas, and that pretty much holds throughout that whole table. I think it's only LA level that there are some variations, but local authorities are not delineated to have more even population sizes, so some of that comes out to play there. So simply because more deprived areas are smaller than less deprived areas, if misclassified, more deprived is likely to be linked to less deprived area. It's simply just by dint of being smaller. So if you're outside of it by being jittered through our method there, you're more likely to be outside, and the same is the case for centroids or postal sector, or certainly for postal district centroids. There is another element which comes in here, which are floor and ceiling effects, that if you are in quintile 5, or the individual should be located in quintile 5, and the linkage is outside of that particular area, it cannot be to a more deprived area, it can only be to a less deprived area. And again, if you're in quintile 1, you can't be classified to a less deprived area than quintile 1, but given that these are invariably the largest areas, you are less likely to find that the misclassification takes you away from quintile 1 in any case. So there's a couple of things at play as to why moving the location away from the original ends up with less deprived situation for some of these linkages. Okay, so I sort of recap where I came in about half an hour ago. So a tension exists between making data available which protects the confidentiality of individuals while containing sufficiently detailed socio-demographic and geographic information to underpin the utility of research. It's likely that both supplier and user do not know the degree to which the decisions made in terms of collection, processing and release affect the utility of research results. So the intention here is to inform data collectors and suppliers about geographic choices for confidentiality protection, and to have advice available to provide reassurance to survey and census respondents, and to have information to the research community on whether research may be fit for purpose. So we've investigated the interplay between two geographical entities, the points for the observations and polygons for the area attributes at a variety of scales, and we've emulated the choices a data collector supplier might make, i.e. coarsening postcodes to sectors, that kind of thing. And we've used analytical approaches that researchers might use, i.e. the whether or not somebody reports good health, and then to use that in a logistic regression with some individual attributes and link to area deprivation. Okay, so in terms of the tactics to protect confidentiality, if you go down the route of linking to geographical areas larger than the most local, so postcodes linked to increasingly higher geographies will most likely result in reduced effect size and difference between area types. Locating the individual by centroid of postal sector or district. So linking from coarsened point to smaller area is ill-advised, though to some degree there will be within area similarity, just as the sort of the neighbour type thing. If you move somebody out, how similar is the neighbour? So how similar are the within area geographies? So if you have a relatively deprived local authority, that will contain a range of within area geographies at different levels of deprivation. So by a degree of luck, a more deprived local authority will have more within area deprived areas, and you might, using these coarsened points, actually locate somebody in an appropriate level of deprivation for the analysis. Linking from coarsened point to a larger area will give similar results to equivalent postcode links. So blurring the postcode coordinates, so jittering up to around 500 meters to 750 meters away from the postcode point will provide very similar patterns to using the original location. So misclassification of exposure relates to area size and similarity of neighbours. So in urban areas, even though areas are smaller, misclassification here seems to be less of a problem than in urban with significant rural and in rural areas where greater than 750 meter jittering links from more deprived to less deprived areas. So that is the general trend, that if there is misclassification, it will be to a less deprived area, which could in itself be the reason for the reduced effect size, as well as the smoothing as you go up geographies. So kind of caveat here, this example is for an England and Wales context in terms of the postal geographies and census geographies, though we've and what may be an urban and a rural area and all those kinds of things. But I think it's reasonable to expect that similar kinds of things would operate in other contexts. Haven't done any references, but that's a list of things that we've been reading, and we've got some files of some literature that we've yet to read. So I will leave it there.